Hi everyone, we're going to graph this piecewise defined function. We're also going, so that's the first thing, or the second thing we're going to do. Then we're going to test for the continuity. We're going to do that first. What we want to know is, since the graph is changing at x equals 2, we want to see if it's continuous at that point, at x equals 2. And we also want to evaluate the function at these three x values. So the first thing we're going to do is test for continuity. And on testing continuity, there's three conditions that must be met. So basically, what we're looking at is what's going on at 2. So our C equals 2. That's what they want us to test at x equals 2. But so that means our C is 2. And we do the conditions in order. If the first condition isn't met, then we don't need to do the other two conditions. So let's test if we have if it even exists. So we plug in f of 2. Now f of 2 is going to go in this one because it has to equal 2. So we plug in to our function here and we get 2 plus 3 equals 5. So it does exist. It's at 5. So f of c is 5 and it does exist. So this checks. Now, condition 2, we have to see if the limit exists at c. So that, and what that means is that the left-hand side of 2 equals the limit of the right-hand side of 2. So, and what you're going to do is just write this out, the limit of the x, as x approaches 2 from the left of f of x, that is supposed to equal the limit as x approaches 2 from the right of f of x. So merely what you do is all numbers, so the first one is to the left. So all numbers to the left are less than 2. So it's this one. So plug in 2 into this, and you're going to get 2 plus 1 equals 3. So that's your limit there. All right, on this one, we want the numbers that are bigger or equal to 2. What's going on with that? So we plug in 2 in here, and we get 2 plus 3 equals 5. Now, for the limit to exist, these two numbers need to equal. And 3 does not equal 5. So condition 2 fails. So we don't even need to go on to condition 3. So this function is not continuous, it's discontinuous at x equals 2. So discontinuous. All right, and we can graph it and we're going to see why it's discontinuous. So here it is. So our main point here is 2 at x. And so I want, what it means by the left of 2 is these numbers in here. So you plug in the 2 in here as we did previous, and 2 plus 1 is 3. So you go up to 3, but it's open interval there because it can't equal 2. But you still have to plug in 2 because you can get very close to that. Now let's plug in 0. We know it's a linear equation, so we just need 2 points. If you plug in 0, we get 1. The slope is 1. So this is what the graph looks like of the left of 2. Okay. Now, we're going to do to the right of 2. So all numbers bigger than or equal to 2 are going to be to the right side here. So plug in 2 first. When you plug in 2, we map to 5, and it can equal 5. So you color that in. Then you need to do another one. So let's do 3. So if you plug in 3, that's going to go to 6. So the slope is 1 on that. So just go like that and continues on. So this is why the condition 2 failed, because as you approach 2 from the left of 2, it gets closer and closer to 3. However, when you approach 2 from the right of 2, it gets closer and closer to 5. Therefore, that's why it's discontinuous, because when you draw, you have to lift your pen up and jump up to here. So this is called a jump discontinuity. And again, that's why condition 2 failed. The limit just means what is it getting closer and closer to on the y value. All right, now we just need to evaluate, and if you did all that other, this should be easy. So f of 0, 0 is less than 2. So we have to use this function. This is your y, remember? So 0 plus 1 is 1. And 10 is greater than 2. So we're going to use this one. 10 plus 3 is 13. And if you use 2, 2 has to equal 2. So 2 is greater than or equal to 2. So you plug it in here and you get 5. And that's it. Thank you. Have a nice day. Bye-bye.